checking.
Hello? Hello?
Check.
Hello? 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 Hello?
Ha?
Low. Hindi ka tamasugod.
Start na, Jason. Sorry.
Unsa?
Start
Ay,
na,
wait,
start.
nag-start na.
Okay,
Sorry.
guys.
Tabian mo yung titumas.
Good evening, everyone. Ngayong gabi.
Good evening. Good evening.
Ikaw na, Jeff.
Hi, sorry. Good evening.
So before we mag-start sa discussion, let's have a recap question. So if you want to answer the question, na ay icon dyan, raise icon, just click it. Then mamili rin yung kinsa mag-answer. Okay, guys. For the number 1, what is the maximum overcurrent for 14 AWG, 12 AWG, and 10 AWG?
Wala ra ba reason?
Anyone? May gusto mag-answer?
Oh, ako, me. Maximum overcurrent.
Okay, Shane.
Ako?
Okay, ikaw. Answer mo, Shane. What is the maximum overcurrent for 14 AWG, 12 AWG, and 10 AWG?
Okay. Sa 14 AW kay 15 amps. Sa 12 AW kay 20 amps and sa 10 kay 30 amps.
Okay,
Ako?
check answer. Answer. 14 AWG is equals to 15 amps, 12 AWG is equals to 20 amps, and 10 AWG is equals to 30 amps. So check. Correct answer mo, Shane. For number 2, what is the color code that reserves the neutral or grounded conductor?
Ako sande.
Okay, Jeff. Ikaw, Jeff.
White.
So correct.
Good evening. Nakakuha na siya. Na-record na ni.
For number 3, what is the color code that reserved for grounding conductor can also be bare?
Ako. Sana.
Okay, Kim. Ikaw, Kim.
Green.
So correct. Green is the answer. Number 4, what are the color code are hot or undergrounded conductor? Anyone, guys? Okay. Vinega, Junior. Okay. Check. So correct to Vinega. Black, red, and etc. For the last question, give me at least 2 metals are allowed for conductors.
Kobe.
One, guys. Okay, ikaw, Curb.
Copper and aluminum.
Okay, check. So there are 3 metals that are allowed for conductors: copper, aluminum, and copper-clad aluminum. So good evening, guys. So we are the group 6, the second to the last group to report. So the reporters are Naya Lendi, and her discussion is cable, raceway, and inclusion requirements. Yours truly, my discussion is branch circuit requirements, branch circuit, types of branch circuits, then Kailing Joby Axin, split wiring receptacles, branch circuit, rating, and load. Sultan Radilin, continuous load branch circuit conductor size, and residential branch circuit wiring. Zacharias Prince Edward, Device and equipment requirements for switches and receptacles, overcurrent protection or circuit breakers and fuses requirements. Tagandong Justin Royal B will discuss weather requirements, switchboard, and panel board requirements. Lastly, Sakuan Allergen T will discuss service and transit equipment requirements, transformer requirements. To begin our discussion, let's have in Nahia Lindy.
Good evening, everyone. I am Landy Nahial and I am here to report about cable, raceway, and enclosure requirements. So first is the cable and raceway requirements. All building wiring must be enclosed in a cable, conduit, wireway, or raceway. During installation, conductors are snaked through conduit or tubing, are laid in a wireway, or are contained in cables and secured to a structural framing. In placing conductors, care must be exercised, as conductors and insulation can be easily damaged. Example of this is that if a conductor is pulled through a tight conduit, it can stretch, and stretching reduces the cross-sectional area of the wire, thereby reducing its ampacity, and it can cause deformation. Also, this creates an unsafe condition because the conductor can overheat. Conductors that are run through a raceway must have sufficient open air space to prevent overheating. The number of current carrying conductors that can run through a raceway is limited by code. So, a current carrying conductor found in a raceway is any ungrounded conductor or grounded conductor. So, katong mga equipment grounding like bare or green colored o katong mga shared neutral conductors kay dili sila current carrying and they are not counted. So here is a table. This table indicates the recommended maximum number of conductors that allowed in conduit or tubing for conductors with THWN or THHN insulation. By the way, THWN stands for thermoplastic, heat, and water-resistant nylon-coated, and THHN stands for thermoplastic, high-heat-resistant nylon-coated. This wire is one of the most common single-conductor wires used in the United States. So back in the table, these recommended values are less than those typically established as maximum values in electrical code. They are recommended maximums because they allow for less cumbersome installation like pulling conductors through conduit and are based on industry experience. So diri nga table makahelp ni siya on making wiring decisions. It is also used to determine how many wires your conduit tubing can safely contain. So there is horizontal numbers at the top of the graph kay diri nato makita ang size and type of conduit. While there is a vertical column kay diri nato makita ang wire gauge. Then there is a central mo ni siya mga numbers represent sa number of wires that can fit for each conduit and correlating gauge. Rigid conduit and tubing are favorite raceway materials that is used to protect conductors in all types of buildings. Because it is available in straight lengths, it must be bent to accommodate changes in direction. To prevent stretching of conductors as they are pulled through the conduit or tube, bends must be made no smaller than the minimum radius specified by code, about 6 to 8 times the conduit diameter. While flexible conduit offers the advantage of easier installation and can be salvaged easily when circuits are rearranged. It is used where mechanical protection is needed and easy relocation of equipment is desired. So typically, conduit and tubing can have up to 490 degrees bends or the equivalent of 360 degrees total in one run. In runs requiring more bends, a pull box is added in the run to assist in pulling conductors and to allow access. Conduit should be supported to prevent wearing away against structure and to avoid stressing its end fittings. So rigid conduit and tubing must be supported within 3 feet of a box or other connection and at intervals of 10 feet or about 3 meters. While flexible conduit must be supported every 4 to 6 inch or 1.35 meters and within 12 inch or 306 feet or about 2 meters between a recessed light fixture and a box. So moving on sa mga cables, we have here non-metallic sheath cable. It is permitted in single and multi-family dwelling units and some other buildings. Kani siya, dili ni siya pwede gamiton sa underground buildings that are more than 3 stories above grade or in commercial garage, motion picture studios, theaters, and places of assemblies, and other corrosive and hazardous location. It must be supported every 4 to 6 inches or 1.35 meter and within 12 inches or 300 millimeter of a box. So next is armored cable. Armored cable or AC is for use in dry and indoor applications. Same sa non-metallic sheath cable, dili gyapon ni siya pwede gamiton sa mga lugar like commercial garage, motion picture studios, theaters, and other corrosive or hazardous location. In armored cable, bends are limited to no less than 5 times the diameter. So it must be supported every 4 to 6 inch or 1.35 meters and within 12 inch or 300 millimeters of a box, except up to 24 inches or 600 millimeters is allowed at points of usage where flexibility is required. AC cannot be embedded in masonry, concrete, or plaster. Before we go to box or enclosure requirements, we should remember that conduit and cable should be installed away from locations where building occupants might use it as a handhold or footstep. Drain holes should be provided at the lowest point in a conduit run. Also, drilling and cooling burrs should be carefully removed to prevent damage to conductor insulation. Box and enclosure requirements. All electrical connection must be made in a protective enclosure such as panel board, junction, or device box, fixture, or appliance. Every switch, outlet, and connection must be contained in an electrical box, and every lighting fixture must be mounted on a box. All wiring must begin or terminate at a panel board or in a box that is a housing switch, luminaire connection, receptacle, conductor junction, or some similar terminal fitting. So nga naman nga ang mga electrical connections must be made in a protective enclosure. It is because para maprotektahan ang mga enclosed electrical equipment from the environment as well as maprotektahan sad ta nga mga users from electrical shock and also to mount electrical equipment. So in here, there are no requirements that specify that a certain type of electrical box be installed for a specific purpose. Instead, the typical trade practice is to install octagonal and round boxes for lighting outlets and to install rectangular and square boxes for switches and receptacle outlets. So normally, round boxes ang mga gina-installs for lighting installation. However, almost any box can be used for any purpose. So, ang kanang conductors nga naa sa electrical box kay need na sila og sufficient open air space para malikayan nga mag-overheat. Therefore, the more conductors and the conductor size, the bigger the box must be. The capacity of box in cubic inches is determined by its length, width, and depth. So, kung mag-increase ang iyang dimension, ang capacity sad sa box kay mag-increase. But some boxes are designed so they can be counted together to increase box capacity. The size and number of conductors to be installed in a box has influences on selecting the type of box and box size. By convention, a conductor that runs through the box is counted as one conductor, and each conductor that terminates in the box counts as one. Fixture wires and conductors that do not leave the box, such as an integral grounding wire, are not counted. So the last one is a table. As we all know, boxes of different shapes and sizes can safely accommodate a varying number of wires depending on their size. The total volume of the box is the determining factor. So this table helps us to designate the number of conductors that allowed in an electrical box based on its size, the type of box, and the wire size. So that's all. Thank you for listening.
Your home's electrical system begins with main service wires that enter your home from an overhead utility line or underground feeder wires and connect to the main service panel, usually located in a utility space or garage. Many smaller homes may not have the option of a utility space or garage, in which case the main service panel may be located on any accessible outside wall. It may also be located outside, but only if it's a weatherproof panel type. So I am Jason and Sagin, and I'm going to report the branch of circuits. So first, let's define the equipment and appliances first. So equipment. Equipment is a general term including fittings, devices, appliances, luminaires for lighting, apparatus, machinery, and etc. used either directly or indirectly in an electrical installation. Appliances or appliance designate utilization equipment, generally not industrial, of common built-in standardized types and sizes, installed as a unit to perform specific functions such as laundering, air conditioner, food preparation, and etc. To differentiate appliances and equipment, appliances is an instrument or device for a specific purpose or task. Equipment, the things needed for a particular purpose. So they are similar and in many cases are interchangeable. Now, what is branch circuit? A branch circuit is part of the electrical system that originates at the main service panel and feeds electricity throughout the structure. There are 120-volt branch circuits that supply power to standard outlets and fixtures, along with 240-volt circuits that power major appliances. A branch circuit is that a portion of a building wiring system that extends beyond the final overcurrent protection device that is protecting a circuit. It provides power from a circuit breaker or fuse in the panel board to single or multiple points of use called outlets. So what is an outlet? An outlet is a point in wiring system where current is taken to supply an appliance, piece of equipment, or lighting installation. It is also known as electrical sockets, plugs, and wall plugs that allow electrical equipment to connect to the electrical grid. To branch circuit, the circuit conductors between the final overcurrent device protecting the circuit and the outlet. The branch circuit conductor shall have an opacity not less than the maximum load to serve. So ang branch circuit kay makita nato siya like if naatay panel board, kanang cable niya na connected siya sa madulong sa lighting or sa outlet, mo na siyang ginatawag na to nga branch circuit. Like ani, natay panel board, ang sulod di ba ni kinay mga functions like lighting, receptacles, and so on. Ang kaniyang cable padulong sa lighting or receptacles, mo na siya itong ginatawag nga branch circuit. In this figure, the left side, example na siya sa general purpose branch circuit. So natay functions like circuit breaker, and kaning linya padulong sa lighting or branch ay sa outlet, ay ginatawag na to siya branch circuit. Circuit breakers are the final overcurrent protection device. In branch circuits, there are 4 primary types of branch circuits, so 4 categories. First, individual branch circuit. Second, appliance branch circuit. Third, general purpose branch circuit. Fourth, multi-wire branch circuit. Now, individual branch circuit. It serves only one receptacle or piece of equipment, such as for a range, clothes dryer, large copy machine, or the other piece of machinery. These circuits usually lead directly from the distribution panel to the appliance and do not serve any other electrical device. The individual branch circuit is sometimes known in the trade as dedicated or special purpose circuit. A branch circuit that supplies one duplex receptacle that supplies 2 cord and plug connected appliances or similar equipment is not an individual branch circuit. So sa individual branch circuit, kay branch circuit siya nga, isa ra siya ma-carry like isa ra ka utilization equipment ang iyang outlet. Ang iyang basta ma-carry niya. So individual circuit kay single outlet lang siya, basta kanang individual kay 120 volts o 240 volts ra ang present voltage ana. So kung gamay ra ang voltage nga makaya, dili siya titira nga gamay ra nga voltage, pero design siya for one single equipment only. So for this slide, di ba natay example, natay panel board. So isa ra siya for for single outlet na gud siya nga makuha niya sa individual branch circuit. So example, we have a panel board, a functions for a circuit breaker for individual. So isa lang gud siya nga makuha sa utilization equipment. Pag duwa gani siya, dili siya ginatawag nga to nga individual branch circuit. So branch circuit, not individual. Appliance branch circuit. It supplies energy to one or more outlets to which appliances are to be connected. They supply fixed electric equipment such as refrigerators, washers, and other large appliance and electrical devices. Sa appliance branch circuit, kay tama na siya sa appliance pero dili niya tama na siya sa appliance like outlet to outlet. Wala siya kanang outlet to lighting taman, but outlet to outlet man gud siya. Appliance branch circuits do not supply lighting fixtures. Appliance branch circuits cannot exceed 20 amps. General purpose branch circuits. It supplies two or more receptacles or outlets for lighting and appliances. This type of circuit may be referred to as lighting circuit. This is carry over from the days when electricity was first used in buildings and its predominant purpose was lighting. It shall not exceed 15 amperes for number 14 AWG copper, 20 amperes for number 12 AWG copper, and 30 amperes for number 10 AWG copper. So after sa outlets na siya ay another branch circuit or connected siya sa lights. Kung mag-exceed ka sa maximum value, possible nga magka-short circuit. Buta, natay circuit breaker for protection kung magkaingana man. Mas thicker nga AWG mas dako ug makarry nga current. Kung nipis ang wire or AWG, tas dako ang amp nga gaplow, dili niya makaya, sumuinit siya. So, appliance branch circuit versus general purpose circuit. So, sa dani nga slide, nakay panel board, circuit breaker for appliance, circuit breaker for general purpose. As you can see, appliance siya taman. So, kaning katulong nga appliance, di ba, nasa lighting. Di ba, ang gingon sa appliance is dili siya maka-supply og lighting. Since kani siya, is appliance man siya, nasulod siya man siya sa appliance. For general, so na siya ipadulong siya sa lighting. So, maka-supply na siya lighting. Required branch circuit. So, na-required ang branch circuit. So, there are circuit breaker, or over current protection. Dapat na siya or minimum 2 20 amp small appliance branch circuits are required. At least 120 amp bathroom branch circuit is required. At least 1 20 amp laundry branch circuit is required. At least 4 20 amp branch circuits are required in addition to ones installed for general lighting and receptacles. 2 small appliance branch circuits, 1 bathroom branch circuit, 1 laundry branch circuit. For the last, multi-wire branch circuit. A branch circuit consisting of 2 or more ungrounded or hot conductors having a voltage between them and a common neutral grounded conductor that is shared between the ungrounded conductors, such as in a 120 to 240 or 240 volt 3-wire circuit. In this circuit, all conductors are the same panel board. Other branch circuits specific to a particular occupancy may also be required. For example, the following branches are required in healthcare facilities such as hospitals, nursing homes, and dental facilities. So in multi-wire branch circuits, a branch circuit that consists of 2 or more ungrounded conductors that have a voltage between them. In a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit, and that is connected to the neutral or grounded conductor of the system. So sa multi-wire branch circuit kay most commonly used sa establishments or hotels. So the most common multi-wire branch circuit is for dishwasher and disposal circuit. To summarize the types of branch circuits, so individual branch circuits is an individual branch circuit supplies only one pieces of utilization equipment. Appliance branch circuit is supplies energy to one or more outlets to which appliances are to be connected. Do not supply lighting fixtures. While general purpose branch circuit, it supplies 2 or more receptacles or outlets for lighting and appliances. For multi-wire branch circuit, it consists of one or more duplex receptacles, one or more multiple receptacles, single or combination. It is the branch circuit with a shared neutral. This means there are two or more ungrounded or hot phase or system conductors with a voltage between them in a shared neutral. Additionally, there are two types of branch circuits. So life safety branch circuit, an emergency system of feeders and branch circuits that provides adequate power to patients and personnel. That is life safety branch circuit. So it must automatically connect to an alternate power source such as generator when the normal power source is interrupted. Example ana is katong makita natin sa mall or hospital, like makita nato dito, di ba, ang exit na sign, mo na siya example sa life safety branch circuit. So critical branch circuit is an emergency system of feeders and branch circuits that intended to provide power to task illumination, special power circuits, and selected receptacles serving areas and functions related to patient care. To critical branch circuits, it must automatically connect to an alternate power source, such as generator, when the normal power source is interrupted. Same sa life safety branch circuit. Take note, the maximum overcurrent for 14 AWG is equals to 15 amps, 12 AWG is equals to 20 amps, 10 AWG is equals to 30 amps. In individual branch circuit has one hot, one neutral. For multi-wire circuits have two hot, one neutral. Color codes for a conductor or wiring. So white is reserved for neutral or grounded conductor. Green is reserved for grounding conductor, can also be bare. Black, red, and etc. are hot, ungrounded conductor. So there are three metals are allowed for conductors. So that there are copper, aluminum, copper clad aluminum. So that's all. Thank you for listening. So I have a question, guys. So if you want to answer, i-chat lang sa tong comment box, ay sa comment, sa chat box. So what are the four primary types of branch circuits? Anyone, guys? Again, what are the four primary types of branch circuits?
Unsa to, Jace?
What are the four primary types of branch circuits? Okay, Nana answer. Okay, thank you, Maria Christine Esteban. Check it. Correct answer. Thank you.
Cindy Kailing, and good evening, everyone. My name is Cindy Kailing, and I am going to discuss to you the split wiring receptacle and branch circuit rating and load. So let's start. So the first things that we are going to discuss is split wiring receptacle. So unsa man ning split wiring receptacle? So split wiring receptacle or split wire duplex receptacles mo ni sila ang klase sa receptacles that are fed with a 120/240 volt circuit having two ungrounded hot conductors, a grounded neutral conductor, and a grounding conductor. So split wiring allows power to be drawn from two separate circuits on one duplex receptacle. So, kaning picture nga inyo nakita sa slide mo na siya ang itsura sa split wiring receptacle. So, as you can see, daghan kaayo wires na ka-attach sa kada side sa receptacle. So, starting off with the left side, makita nato dara ang iyang neutral terminal. Kung asa naka-attach ang white na wire which is known to be the neutral conductor. So, sa iyang lower left part, naka-attach dara ang iyang grounding conductor. So, on the other side, dira nato makita ang iyang mga hot terminals kung asa naka-attach ang two ungrounded hot conductors with the color black and red. So unsa kalahian aning split wiring receptacle from other receptacle? So kani siya nga klase sa receptacle is naa siya ginatawag nato nga connecting tab. Kung asa ga-connect siya sa duha ka hot terminals. So when the tabs are intact, we can connect one hot wire to either hot terminals and connect one neutral wire to either neutral terminal. So both halves will receive power. So usually, pag magpalit ta og duplex receptacles, intact pa jud na iyahang connecting tabs. So to convert the receptacle to a split wire duplex receptacle, we can just simply break off that tab between the hot terminals using needle nose pliers. So if ma-break na nato iyang connecting tab or iyang jumper, they will be independent with each other na, so they will function differently. So when the tab is removed, we must connect a different hot wires na dayon to each of the hot terminals in order to supply power to both halves of the receptacle. So the most common reason for installing one or iyang common jud nga application is that it could allow you to have one half of the outlet remain hot at all times for plugging in appliances, while the other half could be controlled by a wall switch for controlling a desk lamp or some other light fixture. So usually, ang reason jud nga nagagamit ang mga split wiring receptacles is to control the other half of the socket by a switch while the other half remain functional at all times. So for the next slide, I am going to discuss how split wiring receptacle works. So attaching the hot wire in the upper terminal of the split receptacle allows the top half to be hot and the lower half would have no power. So ang kanay niyo nakita karon sa screen mo na siya ang typical nga itsura sa split wiring receptacle. So as we can see, there are three different colors of wires present. So we have color yellow, color black, and color white. So kaning color yellow mo na siya ang atong grounding conductor, and the color black is our hot conductor, while the white one is our neutral conductor. So ang atong grounding conductor is naka-attach siya sa lower left terminal sa atong receptacle, while ang atong neutral conductor naka-attach po siya sa neutral terminal. So on the other side, ang atong black conductor is naka-attach po siya sa atong hot terminals or the upper hot terminal sa receptacle. So sa inyo nakita, ang atong upper socket ra ang naay power or is functional or hot, while the lower half has no power. This is because ang lower terminal sa ato ang receptacle is wala rin naka-connect ng hot conductor. So in this case, ang atong upper socket ra ang functional. Since the jumper is removed or ang connecting tab is removed, so it means that the two hot terminals will function differently. So they are not dependent with each other. Okay, so for the next one, let us consider the presence of the switch. So to connect the lower half of the switch, we can run a white wire from the hot wire nut and take this over to the lower terminal of the switch. Then from the hot terminal of the switch, we can run a black wire over to the lower terminal of the receptacle. So to make the circuit safe, we bring the ground wire also. So in this case, naanay conductor or wire naka-connect sa iyang lower hot terminal. So this is the connection gikan sa switch. And also, we also attach some grounding conductor and neutral conductor sa switch to complete the circuit. So let us see what will happen here. When we power this circuit, we again get electricity to the top terminal. So the switch is currently off, so electricity cannot pass through it, making the lower half of the receptacle to have no power. So if i-on nato atong plangka, ang upper nga socket sa receptacle will function or will remain hot. And that is because naka-off atong switch nga naka-control sa lower terminal sa ato ang receptacle. So why is this? So since naka-off ang atong switch, maka-produce ta og open circuit. So again, unsa gali ang open circuit? Ang open circuit mo na siya ang circuit wherein the current will not flow. So in this way, obstructed siya. So walay kuryente nga mo flow from the hot terminal sa switch to the lower terminal sa receptacle. So that is why walay power or dili hot ang ato ang lower terminal sa receptacle, so it will not be functional. But when we turned on the switch, the circuit is now made and electricity can flow to the lower half also. So diri, pag naka-on ang ato ang switch, maka-produce a closed circuit. So diri, the current will now flow. So from the hot terminal sa switch to the lower terminal sa receptacle. So in this way, ang duha na nato ka terminal will function, and kung asa pwede na maka-plug in bisag asa ani nila to power our appliances. So take note na ang kaning lower terminal is still switchable, so is controlled by the switch. So it means na mo function lang siya if i-on nato ang mismo nga switch, while the other half is permanent na siya nga hot jud. Actually, kani sila is interchangeable. Pwede pod nga ang ato ang upper terminal is controlled by the switch, while the lower terminal is himuon nato siya nga permanently functional. So if magwonder mo if ang inyong receptacle isa ra ka buo ka socket ang mo function, maybe that is because ang inyong receptacle is a split wiring receptacle wherein the other half is controlled by switch. So maybe if i-on niyo tong inyong specific na switch, then mo function pod ang other half sa inyong receptacle. So I hope nasabtan ra ang split wiring receptacle. So now let us proceed to the branch circuit rating and load. So the branch circuit rating is determined by the rating of the overcurrent protection device, fuse or circuit breaker used to protect the wiring and the circuit from excessive current flow. So the rating of the overcurrent protection device is related to the connected load or loads being fed by the branch circuit. So basically, ang kaning branch circuit rating is defined by the rating or the setting of its protection device or protective device. So it is the maximum permitted ampere rating or setting of the overcurrent device. Well, we also have here the term connected load. So on a branch circuit, it is the sum of all loads connected in a circuit. So it is found by totaling the connected volt amp or VA load at each outlet connected to the circuit. So design of a building electrical installation involves computations with power expressed in watts, voltage in volts, amperage in amps, and volt amps in volts and amperes. So a summary of a conversion formulas for direct current and alternating current systems is provided in table 19.9. Kaning table nga nakita ninyo karon sa screen. So these formulas are useful in determining loads and circuiting design. So when we design an electrical system or electrical installation, it's not just all about designing a safe and reliable system, but also involve Japon ang mga computations in order to guide the designers and engineers in designing the system to be safe once energized. So actually na-again na nato ni siya sa atong previous lessons kaning mga formula. So we are just going to refer to this table in order to find the DC power in watts, AC real power, AC apparent power, amperes, and the power factor. So dire pangitaon lang nato ang appropriate formula nga atong gamiton based sa atong system. So we're just going to look sa direct current system, baka or sa AC current systems. So naapod siya note dire nga for two-phase 3-wire alternating current system, we're just going to substitute 1.41 for 1.73. And for two-phase 4-wire alternating current system, we're just going to substitute 2.00 for 1.73. So we are just going to substitute the following values kani 1.41 and 2.00 diri sa three-phase system ng formula kung asa lisda nato ang 1.73. Okay, so the design of a branch circuit involves sizing conductors and overcurrent protection or fuse or circuit breaker that match the circuit rating. So volt amperage or VA loads and corresponding amperage in A loads on single phase and three-phase circuits for various system voltages are provided in tables 19.10 and 19.11. So in designing, we are also going to follow certain standard when it comes to sizing sa mga conductors and overcurrent protection device in order to match the circuit rating. So first nato i-discuss diri ang table 19.10. So diri sa table 19.10 makita nato diri ang volt amperage loads and corresponding amperage loads on single phase and the three-phase circuits for various system voltages based upon a power factor of 1.0. So it is divided into three parts na atay load sa first column, amperage sa middle, and load also for the last column. So under sa amperage na atay mga voltage ratings diri for single phase circuits, and under sa three-phase circuits na atay mga voltage ratings pod. So unsaon ipagkuha ning mga amperage diri? We're just going to use the formula nga naa sa table 19.9. So for single phase circuits, in order to find the amperage, so yung formula is volt amps over the voltage. So for the three-phase circuits, we are going to use the formula volt amps divided by 1.73 times the voltage in order to get the value. So same process apply in all of these, and since given naman siya, we're just going to refer to this table para di na ta mag-solve. So for the table 19.11, we have here the maximum connected loads, voltages, and requirements for common 120 volts residential circuit ratings. So as you can see, it is divided into 7 columns. So the first column na today 120 volt circuit rating in 15 amps, 20 amps, 30 amps, 40 amps, and 50 amps. The second column, we have here the maximum 100% connected load in volt amps. So third, nato the maximum continuous load, which is 80% of the connected load in volt amps also. And so fourth column, we have here the 50% of maximum load in volt amps. And for the fifth column, we have here the suggested or the typical conductors, excluding grounding in AWG. And for the sixth column, we have here the overcurrent protection in amps. And the last column, we have here the recommended uses. So taking for example, the 15 amps 120 volt circuit rating. So in order to find its maximum connected load, we are just going to multiply 15 amps by 120 volts. So your answer is 1,800. And for its maximum continuous load, which is just 80% of the connected load, we have here 1,440. So gikuha ra ni by taking 80% of the 1,800. And to get the 50% of its maximum load in volt amps, we're just going to take the 50% of 1,800. So we have here 900. And for the typical conductors, so this is the suggested conductors to be used given the following volt amps, and also the rating of the overcurrent protection devices. You've noticed equal lang sila sa atong first column since the overcurrent protection device is related ra siya sa circuit rating sa load. And also sa last column, we have here the recommended uses niya. So for the 15 amps, 120 volt circuit rating, ang iyang recommended uses is for lighting and individual circuits. So same rules apply na dayon from the remaining values diri sa 120 volt circuit rating. Okay. So general purpose circuit. So general purpose circuits feed more than one outlet for lighting or other purpose. So according to requirements, the rating of general purpose branch circuits must be 15 amps, 20 amps, 30 amps, 40 amps, or 50 amps. So general purpose circuits are typically limited according to what will be connected to them. So there are some limitations here in general purpose circuits. So let's get to know them. So number one, when a general purpose circuit feeds fixed appliances and luminaires or portable appliances, the total of the fixed appliances should be no more than 50% of the branch circuit rating. So assuming a 15 amps 120 volts branch circuit, it would have a maximum rating of 15 amps times 120 volts, which is equal to 1800 volt amps. So in this case, the fixed appliances would be limited to 900 volt amps. So what happens to the other half? So we should have to leave the other 900 volt amps available to supply luminaires or portable appliances, which also served by the branch circuit. Number 2, a 20 amps 120 volts branch circuit would have a theoretical maximum of 2400 volt amps. So we are just going to multiply 20 amps by the 120 volts, so it equals 2400 volt amps. So it is actually common to practice the limit of the connected load to 80% of the circuit rating. So 20 amps times 120 volts times 80%, which is equal to 1920 volt amps. Number 3, when the load on the circuit will be a continuous operating load, such as store lights, the total load should not exceed 80% of the circuit rating. So for example, we have here a 15 amps branch that has a full rating of 1800 volt amps. So the limit would be 80% or 12 amps and 1440 volt amps. So solving this one, we have here 15 amps times 120 volts times 80%. So yang 80% is 1440 volt amps. And for a 20 amps 2400 volt amps branch, yang limit is also yang 80%. So which is the 1920 volt amps. Number 4, when portable appliances will be used on a general purpose circuit, the limit for any one portable appliance is 80% of the branch circuit rating. And number 5, in commercial applications, convenience receptacles are computed at a load of 1.5 amps, which is 180 volt amps, per receptacle and are limited to 80% of the rating. So this limits a branch circuit serving only receptacles its rating divided by 1 and 1/2 amps. For example, a 15 amp circuit is limited to a maximum of 8 outlets and a 20 amp circuit to 10 outlets. Individual circuit. So these circuits provide power to a single outlet, such as a receptacle serving a range, clothes dryer, or copy machine. Although there are no size limitations for an individual circuit rating, appliances and equipment rated at above 25 amp must be placed on a separate individual circuit because of the 50% maximum single load limitation in general purpose circuiting. Usually, connected loads above 20 amps are placed on an individual circuit, so it is a good practice to provide individual circuits for loads above 1500 watts. Next is the appliance circuit. So these circuits serve 2 or more outlets to which only appliances are connected. So in dwelling units, 2 or more 20 amp small appliance circuits for convenience receptacle outlets in the kitchen, dining room, pantry, and breakfast room are required. So these are in addition to the other outlets required, such as range, waste disposal, and so on. So small appliance circuits can supply any refrigerators and freezers, but not an electric range or oven. So a light fixture is not permitted to be permanently connected to a small appliance circuit unless the light fixture is part of the appliance, such as an oven or clothes dryer light. So a minimum of one 20 amp circuit is required to serve the laundry room convenience receptacle. So any other special requirements such as an electric clothes dryer requiring 120 over 240 volts must also be provided. So that's it for my report. I hope that you've learned something and thank you for listening.
So now let's have Rosalie Sultan for her discussion.
Hi, good evening guys. Wait lang ha, mag-share screen ako. Naana?
Yes, Nana.
Okay, so good evening everyone. I am Rodeline Sultan and I am the next reporter. And in my report, I have three main topics. So the first one is the continuous load, followed by branch circuit conductor size, and the last one is the residential branch circuit wiring. Now let's have first the continuous loads. What is continuous load? A continuous load is a connected load that operates for 3 hours or more at any time. The National Electrical Code also defines it as a load where the maximum current is expected to continue for 3 hours or more. So when we say maximum current or maximum continuous load, it is the highest level of load that should be maintained within a particular period. Any type of load that runs for more than 3 hours is considered as continuous load. And we also need to consider nga dapat na i-limit ang amps of electricity or power nga gikuha gikan sa source para effectively ma-manage ang energy usage para pod ma-conserve ang energy and at the same time ma-prevent ang corrosive effect sa inefficient power usage. And when determining a circuit rating, most loads deemed continuous must have a circuit rating calculated at 125% of the circuit's connected load. Now, what is 125% rule? 125% rule is when we're dealing with continuous loads, which is any load that expected to run for 3 hours or more. Then we i-apply na to ang 125% na rule. Now, let's have our first example. A lighting installation containing 16 to 100 watts incandescent luminaries on one circuit will be operated approximately 10 hours per workday. Determine the circuit rating. So to get the power, we just simply multiply 16 and 100 watts, and that is equals to 1,600 watts. And 1,600 watts is a connected load is a continuous load because it operates for 10 hours and the continuous load multiplier is 125 and that should be applied. Now we have 1,600 volt amps times 1.25 and please note that lights generally have power rating equals to their connected load or volt amps. Kumbaga, ang watts is equals to volt amps rating maong nahimong 1,600 volt amps ang 1,600 watts. So 1,600 volt amps times 1.25 is equals to 2,000 volt amps. Now, circuit rating can be solved by using the formula I is equals to P divided by E. So just simply substitute the value. So we know nga ang 2,000 volt amps is a young power and divided by nato siya sa 120 volts. So kaning 120 volts is gikan ni siya sa 90 na siya sa table point 19.13 where ina-added to ang equipment nga incandescent light luminaries and iyahang value sa voltage is 120 volts. So 2,000 voltage amps divided by 120 volts is equals to 16.17 amps. And based sa table 18.3, mangita tag rating sa circuit breaker nga duol sa 16.7 amps. So, ang 20 amps ang rating nga duol sa 16.7 amps. Though duol pod ang 15 amps, but dili ta pwede mo gamit og circuit breaker nga ubos ang rating sa 16.7 amps. Dapat katong duol nga higher sa iyahang value atong gamiton. So, and 200 amp circuit breaker is the closest circuit breaker available for overcurrent protection. The rating for the circuit is also 20 amps. So there are several exceptions to application of the continuous load multiplier. On circuits involving electric space heating, the connected load is taken at 100% of the load even though it may operate for more than 3 hours at a time. And any branch circuit serving a single motor or a device containing a motor should have an ampacity or amperage rating of not less than 125% of the motor's full load current rating. So this is the same as saying that no motor can exceed 80% of the branch circuit rating. And based po sa akong research, if single wire or one current lang ang naa sa given, gamiton nato ang 125% nga continuous load multiplier, and if double wire siya, dira na ta magamit og 80% nga continuous load multiplier. Now let's move on to the next topic, which is the branch circuit conductor size. On a branch circuit, conductor size is tied to circuit rating. Generally, undergrounded or hot and grounded or neutral conductors in the circuit must be sized so that the conductor ampacity is at least the branch circuit rating. The ampacity of a conductor can be larger than the circuit rating but not smaller. For example, the number 8 AWG copper conductor with PHW insulation that will be used in a 120 volts two-wire circuit in an environment with an average ambient air temperature of no greater than 86 degrees Fahrenheit or 30 degrees Celsius has an ampacity of 50 amps. It can safely carry up to 50 amps without overheating. So, meaning to say, ang 50 amps nga overcurrent protection device, either circuit breaker siya or fuse, is makaprotect sa circuit nga nakawire anang conductor kay ang overcurrent protection device is mag-disconnect if ever malampas ang current sa 50 amps. Now we have example number 2. A clothes dryer rated at 5 kilowatt is connected to a 120 or 240 volts single-phase 3-wire individual branch circuit. Determine the following. A. The connected full load in amps. B. The minimum size circuit rating of the overcurrent device and the minimum copper wire size based on PHW and 2 insulation at a temperature rating of 167 degrees Fahrenheit or 75 degrees Celsius. Neglect any correction factors for temperature and conductor bundling. And letter C, the rating of the receptacle and plug used to connect the clothes dryer. Now, sa letter A, we are asked to determine the connected full load in amps. And the atong gamiton nga formula is I is equals to P divided by the E. We all know nga ang 5 kilowatt is equals to 5,000 watts. And we also know nga ang 5,000 watts is equals to 5,000 volt amps. So using the formula, we now have 5,000 volt amps divided by 240 volts. And this is equals to 20.8 amps or round up 21 amps. Next, we are asked to determine the minimum size circuit rating of the overcurrent device, and the minimum copper wire size based on THWN2 insulation at a temperature rating of 167 degree Fahrenheit or 75 degrees Celsius. So neglect any correction factors for temperature and conductor bundling. First, we are asked to determine the minimum size circuit rating of overcurrent device, which can be found in Table 18.3. Now, from Table 18.3, the minimum size overcurrent device that can be used at 21 amps na circuit is 25 amps. So, ako kabalo anong walay 25 amps dire, pero nag-research ko to verify and naay 25 amps sa sa NEC katong National Electrical Code na book. So, the minimum size overcurrent device that can be used on this circuit is 25 amps. Next, we are asked to determine the minimum copper wire size based on THWN to insulation at a temperature rating of 167 degree Fahrenheit or 75 degrees Celsius. So mag-base ta diri and naatay rating na 30 amps. And ang size sa 30 amps is 10 AWG. So therefore, AWG number 10 copper conductor rated at 30 amps is the minimum required. Next, we are asked to determine the rating of the receptacle and plug used to connect the clothes dryer. From table 18.6, based on a 30 amps circuit rating, a 3-pole, 4-wire, 14 to 30R receptacles and 14 to 30P plug rated at 30 amps, 125 over 120 volts, grounding 3-pole, 4-wire. So, muna siya ang rating sa receptacle and plug na gamiton para sa clothes dryer. Moving on to the last topic, we have residential branch circuit wiring. So when we say residential branch circuit wiring, this wiring design refers to the circuit design of the circuits that supply electricity to different areas in the home. And we now have the NMB cable or ROMIX 12/2 cable. Mao ni iyahang picture, and NMB stands for non-metallic sheeted cable. So non-metallic siya because it has a PVC jacket instead of a metal-clad jacket. So kaya siguro yung color yellow iyahang ginamin sa jacket, no? And NMB cable is the most widely used wiring method in residential dwellings. So it is commonly used for residential wirings of luminaries, devices, and appliances. And NMB cable must have 194 degree Fahrenheit or 90 degrees Celsius conductor insulation rating, which is designated by a B on the cable sheet. Next, we have AWG number 12 and AWG number 14 and AWG number 10/2. So AWG number 12 and number 14 are used for receptacles and lighting circuits, and AWG number 12/2 is commonly used for electric water heaters. Next, we have AWG number 10/3 and AWG number 8/3 and number 6/3 with ground. So AWG number 10/3 is used to wire outlets for air conditioning units, electric dryers, and small ovens or stove. And AWG number 8/3 with ground or AWG number 6/3 with ground used for ranges and wall-mounted ovens. And lastly, the type SER or other 4-wire cable. So SER is a round service electrical cable that typically has up to 4 conductors and a bare neutral. It is used for electrical ranges, cooktops, wall ovens, and clothes dryer. Tomorrow to akong report now. Thank you.
So, good evening guys. Madunggan na ba? Hello?
Possible, bro.
Ha? Madunggan ba? Sige, sige. So, ang akong report is, good evening everyone. So, I'm Prince Edward Zacarias and my report is about device and equipment requirements. So, under ato, so, muna ang mga requirements for switches and receptacles. So, switches must be selected to match the load they control. Large lighting installations that require many switches may have the switches contained within a panel board like enclosure called lighting control panels. Saka na makita niya picture sa ubos mo na siya. So, next is receptacles must be selected to match the appliances or equipment they serve. So, ang pasabot lang gid niya kay i-match nimo ang proper nga support switch sa kuan lugar example inyong balay nang basic lang gid na switch kay naman sa balay pero pag kanang nasa mga dagko nga buildings or ano ba kining mga kini panel board lighting kining control panels so apil pud sa receptacles so kung ang imong appliance kay na ay kanang kailangan so mopalit pud kag receptacle nga na ground so ngana gid ang isa so next slide so next is proper heights for electrical wall switches so for standard construction or kanang ang ipasabot ana is kanang mga sa balay or kanang any construction kanang standard siya. So more ang basic bitaw niya. So ang wall switches boxes are somewhere between 48 and 52 inches above the floor. So kamantay mo ang mga switches sa inyong balay nga mag 48 inches so 4 feet nga na. So magtamon sa inyong liog nga na ginang standard. So next is residence with physical limitations. Ano yung mga residence with physical limitations ka na bitaw mga members sa family nga PWD or mga expansanan. So, if one member of your family is considerably shorter than average or uses a wheelchair, wall switches must be set at 36 inches above the floor to put them in easy reach of residents in wheelchairs. So, mo na siya. So, kung na residents with physical limitations, i-install nato atong electrical wall switches na mas mubo-mubo. So, 36 inches or mga 3 feet. So, kaya na kaya nila mag-reach. So, next is hot tubs or whirlpools. So, kini, kasagara ni siya na asa mga switches daw, di ba? Wak man guys switches sa ito. Kasagara, nara ni sa mga reach ng mga pang-reach ng balay. So, kung naaman gali switch, dapat, according to NEC, the NEC has a very specific requirement on the location of the switch. It must be 5 feet away from the tub. So, dapat layo siya sa tub kay para dili siya mawisik-wisikan nga na di ko siya mabasa. Tapos ano siya napag nalimpag butang ani dapat taas pud ni siya ang pagkabutang sa switch mga 48 inches or above. Tapos kini di siya tanan guys pili po na siya dili siya subayon jud kung iingon sa tag-iya kung naa siya specification nga ngani siya magbuot hindi pa pud na siya. So next So, next is proper heights for receptacles. So, kini, dali yapon gini, basic yapon nito. So, for standard construction, convenience receptacles are normally mounted approximately 16 inches above finished floor or 400 millimeters unless otherwise specified. So, kabantay mo siya mo nga mubo gina ang nagina sa ubos kapit ang mga receptacles yan. Mo po ng mga standard. So, 400 millimeters. So, mo na siya. So, for bathrooms, ano sa mga nagkutig nga balay na ay mga bathroom system na ay mga receptacles, mga outlets. So, kung naana sa bathroom, convenience receptacles in bathrooms and restrooms are normally mounted approximately 44 inches. So, taas-taas siya kaya para mo pa ng purpose dili kasi mabasa kung maglunok man sa salo ganana. So next. So, receptacle installation. So, sa pag-install sa receptacle, wala ba mo na tingala guys nga kanang naa kanang sa picture ito na ay ang ground slot kay naa sa taas o naa sa ubos. So, sakto yun na ang ground slot kay naa sa taas sa tabasan. It's recommended that the receptacles be installed with the grounding slot oriented upward in contrast to historical practices. So this recommendation is made to improve safety with the grounding pin of a plug installed so it is oriented downward as is common practice. If a metal object, example mga tool or kitchen utensils, falls and strikes a grounded plug, the first blades the first blades that the object could contact are the ungrounded or hot and grounded conductors. A contacting condition would result in a short circuit and arcing. By orienting the grounding slot upward, the grounding pin would be the first blade to contact the object, which would not create a short circuit. So, nasabtan nyo ito guys. So, ang pasabot niya nga, kung kanang sa picture pa, kung kanang incorrect without, kung ang grounding slot na sa ubos. So, kung matagakan na sa mga metal nga, mga gamit, so, di ba ang makontak niya kay ang mga nasa taas nga part which is ang hot ug ang ground ang hot nga kuan. So makakos do na siya og short circuit and arcing. Pero kung ibali nato kanang grounding slot nasa taas, kung mao na unang maigo, so wala siya mahitabo. So safe siya for safety purposes na siya. So next. So overcurrent protection, for circuit breakers and fuses requirements. So, wait lang. So, an overcurrent protection or OCP device, a fuse or circuit breaker serves to limit current levels in a conductor by interrupting power when current limitations are exceeded. It prevents excessive heat from damaging conductors and related equipment. Therefore, the overcurrent device must be matched to the conductor and equipment so that the current carrying capacity of the conductor and equipment are not exceeded. So next, so the the current carried by or amperage by the electrical circuit or system protected by an OCP device must not exceed the maximum current of the circuit breaker. So additionally, conductors must be protected in accordance with their ampacity. For example, a circuit with a 20 ampere rating should have a 20 ampere fuse or circuit breaker protecting it, and the ampacity of the conductors in the circuit must have an ampacity after corrections of at least 20 ampere. So, ang pasabot ana niya, wag na ingon gud sa reporter ganina. So, kung naakay ka ng circuit breaker nga ang yang kwan is 20 ampere, so dapat dili ang imong system po dapat dili siya mulapas ana. Kung dili dili siya madaot or kanang mag-twist off. So next. So the voltage rating of a fuse or circuit breaker must be equal to or greater than the voltage of the circuit in which the fuse is applied. For power systems of 600 volts or less, fuses of higher voltage rating can be applied on circuits of a lower system voltage. So for example, a fuse rated of 600 volts can be used on a 480 volt system. So, ang conclusion na ito guys kay kanang dili lang gid siya manglapas sa kanang gihatag niya nga kanang amperage or voltage. So mao gini sa ang ang ginapasabot gid ng overcurrent protection requirement. So lang yun siya. Ako ganito. So mga mo to tanan guys. So thank you. So proceed na sa next reporter.
So, good evening everyone. Now I'm going to tackle the feeder requirements, switchboard, and the panel board requirements. Next slide, bro. So for the first topic, these are the feeder requirements. First, let us define feeder. Next slide, bro. In electrical engineering, a feeder line is a type of transmission line. In addition, feeders are the power lines through which electricity is transmitted in power systems. Feeder transmits power from generating station or substation to the distribution points. Next slide, bro. For the first requirement, you need to know its conductor size. Feeder conductors shall not be required to be larger than the service entrance conductors that supply the dwelling unit. So dapat ang imong feeder conductor dako no kay mas gamay siya sa service entrance nga mo'y mo supply sa tagsa-tagsa nga mga kabalayan. Next slide, bro. Next, the feeder loads. The minimum load in amperes shall be calculated in accordance with the load calculation procedure prescribed in Table E3704.2. The associated table demand factors shall be applied to the actual load to determine the minimum load for feeders. Next slide, bro. So this is the feeder load calculation. For load calculation procedure, first, lighting and receptacle, plus the appliances and motors, next plus fixed motors, plus electric clothes dryer, next slide, bro, plus the cooking appliances, and lastly, plus the largest of either the heating or cooling load. So for the largest of the following two selection, first, 100% of the nameplate ratings of the air conditioning and cooling, including the heat pump compressor. Second, 100% of the fixed electric space hearing. So note that for SI unit, 1 square foot is equal to 0.0929 m squared. Next slide, bro. So the next is the feeder neutral load. The feeder neutral load shall be the maximum unbalance of the load determined in accordance with this chapter. The maximum unbalanced load shall be the maximum net calculated load between the neutral and any one ungrounded conductor. For a feeder or service supplying electric ranges, wall-mounted ovens, counter-mounted cooking units, and electric dryers, the maximum unbalanced load shall be considered as 70% of the load on the ungrounded conductors. Next slide, bro. So the next is the lighting and general use receptacle load. A unit load of not less than 3 volt amperes shall constitute the minimum lighting and general use receptacle load for each square foot of floor area. 33 VA or volt ampere for each square meter or floor area. The floor area for each floor shall be calculated from the outside dimensions of the building. The calculated floor area shall not include open porches, garage, or unused or unfinished spaces not adaptable for future use. Next slide, bro. So for the next requirement, dampacity and calculated loads. The calculated load of a feeder shall be not less than the sum of the loads on the branch circuit supplied, as determined by section E3704, after any applicable demand factors permitted by section E3704 have been applied. Next slide, bro. So, and the last requirement is the equipment grounding conductor, where a feeder supplies branch circuits in which equipment grounding conductors are required. The feeder shall include or provide an equipment grounding conductor that is one or more or a combination of the types specified in section E3908.8, to which the equipment grounding conductors of the branch circuits shall be connected. Where the feeder supplies a separate building or structure, the requirements of section 607.3.1 shall apply. Next slide, bro. So for the next topic, let's tackle about switchboard requirements. First, let's define switchboard. An electric switchboard is a device that distributes electricity from one or more sources of supply to several smaller load circuits. It is assembly of one or more panels, each of which contains switching devices for the protection and control of circuits fed from the switchboard. Several manufacturers make switchboards used in the industry, commercial buildings, telecommunication facilities, oil and gas plants, data centers, healthcare, and other buildings, and onboard large ships. Next slide, bro. Inside a switchboard, there will be one or more bus bars. These are flat strips or copper or aluminum to which the switchgear is connected. Bus bars carry large currents through the switchboard and are supported by insulators. Bare bus bars are common, but many types are now manufactured with an insulating cover on the bars, leaving only connection points exposed. Next slide, bro. So, dapat ang ganang switchboard, mura gyapon siya ganang pare-parehas gyapon siya sa panel board na kinahanglan siya enclosed. So, modern industrial switchboard are metal enclosed and of dead front construction. No energized parts are accessible when the covers and panels are closed. Previously, open switchboard had switches and other devices mounted on panels made of slate, granite, or ebony asbestos board. The metal enclosure of the switchboard is bonded to earth ground for protection of personnel. Large switchboard may be freestanding floor-mounted enclosures with provision for incoming connections at either the top or bottom of the enclosure. Next slide, bro. So for my last topic, let's tackle the panel board requirements. So an electrical panel board is also called a distribution, electric or breaker panel. Hence, a panel board is a basic part of the electricity supply system. A panel board is an enclosure that shares the electrical power feed into separate circuit units by providing a fuse protector or a circuit breaker for each circuit. So what are the components of panel boards? So first, it must be enclosed. So this is usually a box that houses the other components of the electric panel. It has an element of galvanized or painted steel to protect the internal equipment. So pareha gyapon siya sa switchboard. Prepare sa sila na dapat gyapon siya secured and enclosed. So second is the chassis. This is the internal component of the electric panel. It is composed of the overcurrent protection device, control device, bus bars, and other components which mount or support rails. So kaning chassis, pareha gyapon siya sa kanang example kan ibutang nato kana sa motor. Kanang body bitaw kanang kaputanan siya sa kanang mga pisa inana. Kinahanglan gyapon ang kaning panel board. Nagyapon siya chassis which support the rails. So third is the label. It provides information voltage rating, interrupting capacity, manufacturing date, panel vintage, and renewal parts. Next slide, bro. So, fourth is the dead front and trim. This is the front cover piece of the enclosure. They cover the surface of the front surface of the panel board. They also provide a hinge access door that gives access to the circuit breakers. The dead front and trim also prevent contact with the interior component when operating. Filler plates cover any unused pole space that the circuit breaker has not yet utilized. And last, bus bars. These are aluminum or copper conducting strips. It is a conductor that serves a standard connection between two or more circuits. Hence, it carries a large amount of current from the incoming meter line to the different circuit breakers in the panel board. Next slide, bro. So how does an electric panel board work? So power lines deliver electricity to houses via poles or underground cables. As a result, the wires transmit power from the electric meter into the breaker box via the electric meter. It is now the it is now from here that power is shared throughout the circuits or sub-panels of the house. Since the power line connects to the electric meter, the main circuit breakers pulls the power to complete the circuit. This is further transferred to the charge bus bars. The bus bars the bus bars then transfer the electricity to the remaining circuit breakers. Next slide, bro. So, according to Article 408, Chapter 3, 408.30, the panel board requirement, according to the NEC or the National Electrical Code or NFPA 70, uh, all panel boards must have a rating that should not less than the minimum feeder capacity required for the loaded calculated in section 2, 2, 3, 4, or 5 of Article 220 as applicable. And also also according to the overcurrent protection of panel board, the NEC says that in addition to the requirement of Article 408.36, an overcurrent protective device having a rating not greater than that of the panel board itself should protect a panel board. This overcurrent protective device should be located within or at any point on the supply side of the panel board. So thank you for listening. Then guys, nakoy pangutana dayto. So kinsay mag-volunteer ay magpili na lang kog isa ka kuan classmate nako. Pwede si kuan Shane, na si Shane.
Yeah.
Nakoy pangutana. So ready na ka? Shane, are you still
Uy,
there?
dili po. Sige, go. Unsa na.
Okay. Nagkaw na ka Shane.
Mana.
Bitaw mga question, narang question. So, under the switchboard components, identify these flat strips of copper or aluminum to which the switchgear is connected. What do you call that one?
Bathboard?
Hapit
Basboard?
na. Hapit na. So, ang answer is bus bars.
Ay, busbars, guys. Sorry.
So, for the next question, na si Lovely.
Yes, bro.
So, Lovely, give one requirement for feeder and explain it to the class.
Conductor size.
Yes.
Conductor size feeder conductor shall not be required to be larger than the service entrance conductor that supplies the dwelling unit. Marita siya.
Okay, thank you so much for participating. Next reporter, please.
Good evening, everyone. I'm Arlie Sakwan. So I'm the last reporter for this group, and my topic is about service entrance equipment requirements and transformer requirements. Next slide, please. Service entrance equipment requirements. So, let's review. Ang service is the conductors and equipment for delivering energy from the electricity supply system to the wiring system of the premises served. So, ang service entrance includes the components that connect the utility supplied wiring, the service lateral or service drop, to the service disconnect, excluding the utilities metering equipment. In short, service entrance is part of the electrical installation. So service entrance equipment is receives the service entrance conductor. So next slide, please. Next slide. Thank you. Service equipment. So ang service equipment must be large enough to supply the computed load of the building or area of the building being served. It is calculated using code requirements and utility regulations. In most commercial and industrial installations is kanang commonly ragyod kanang 6 service disconnects per service are allowed. And then makita man nato sa pictures nga unom ra gyud siya tama ng iyahang disconnects per service. So next slide. Table 19.18, nag-show ni siya sa minimum size conductor for service entrance conductors for RHW, THWN, THHN, XHHW, unused conductors. So kaning 100 amps, 125, 150, 175, 200 amps. So most common sizes of residential service equipment ni siya. So wait lang. So in single-family residence and multi-family dwellings, the main service panel board can be mounted either outside or inside the dwelling as near as possible to the point of entrance of the service conductors to the building. So all service equipment and electrical panels shall have a clear area nga ang wide niya is 30 inches or 0.75 meter. And ang yang deep in front is 36 inches or 0.9 meter. Wait lang. Next slide. Thank you. Wala na ko. Generally, all electrical service entrances rated at 250 volts and over or exceeding 250 amps must be located in a separate room used for no other purpose except that telecommunications equipment may terminate in that room. Where a separate electrical room is required, it should have a 1 HR fire rating unless the building and room is sprinklered. So, ang boiler and furnace rooms are not acceptable for service entrance or main distribution equipment. No pipes containing a liquid should enter that room unless the pipe terminates in that room and is intended for use in that room. So, it is necessary to maintain safe working clearances from overhead electrical conductors to reduce risk of accidental contact. So kaning mga required clearance niya, makita ni siya sa code, sa NEC. So typically, ang minimum vertical clearances of 18 feet or 5.5 meter above roadways, 12 feet above driveways, and 10 feet above sidewalks are the required minimum. An 8 feet or 2.4 meter clearance is required above low slope na siya. Then ang less than 4 inches 12 slope for rough lines. A 3 feet or 0.9 meter clearance is required for step slope roofs. So, next slide. Buried underground conductors. So, Necessary ang Barrican underground conductors sufficiently below sa grade to reduce the hazard of unintentional contact. The required tips of burial can be found. Makita gyapon siya sa code sa NEC. So, ang minimum earth cover varies from 6 to 24 inches or 150 to 600 millimeter, depending on whether the conductors are in cable or protected by a conduit or covered with soil or below a concrete walk or street. So, the maximum single that utilities will run overhead service drop conductors to the point of service entrance varies, but typically it is 100 to 125 feet or 30.5 or to 38.1 meter. So, ang building heights niya or large conductors or the necessity for street, driveway, or sidewalk crossing may reduce maximum permissible spans. So, next slide. Transformer requirements. So sa transformer, wait lang. So sa transformer is a piece of static electrical equipment which transforms electrical energy to the magnetic energy and again to the electrical energy. Muna na siyang secondary transformer side. So transformer is known to use for step down or step up the flow of the current. Example from 440 volts to 220 volts. So ang transformer commonly found siya sa substations. So also used for generating power plant like geothermal electrical power plant or hydroelectrical power plant. So natay 4 transformer combinations. Y to Y, delta to delta, delta to Y, Y to delta. So ang Y to Y is suitable for transformer application that do not need a neutral on the primary side. Delta to delta is recommended for projects that does not need a neutral on the secondary side. So delta to Y are commonly found in industrial facilities and the most commonly found transformer combination. So muna siyang pinaka-common. So ang Y to delta is found in 3 wires transformer applications requiring a neutral and service of loads the secondary side. So the reason for choosing a Y or delta configuration for transformer winding connections are the same as for any other 3-phase application. Next slide, please. Y connections provide the opportunity for multiple voltages, while ang delta connections enjoy a higher level of reliability. If one winding fails to open and the other 2 can still maintain full line voltages to the load. For example, when there is no need for a neutral conductor in the secondary power station, magamit tag delta to delta connection schemes are preferred because of the inherent reliability of the delta configuration. So a 480 volts primary, 208 volts Y over 120 volts secondary. 3-phase transformer is a popular unit used in a large commercial. So muna siyang popular ang 3-phase transformer, buildings and industrial facilities. So from a 4-wire 480 over 277 volts supply, 277 volts for lightning and 480 volts for heavy equipment can be powered before being stepped down to 208 Y over 120 volts. So ang 3-phase or 4-wire system for convenience receptacles and light-duty equipment and appliances. Next slide. So sa table 19.19, this is the approximate full loads amperes for single-phase and three-phase transformers. Values will vary with unit checked with manufacturer for actual specifications. So noted that for motor service factor greater than 1.0, increase full loads amps proportionally. So example is service factor nimo is 1.18, increase imong amperage values by 18%. So, dani sa table, standard na ni siyang nasa table. Magdepende ra dayon ang rating sa flow of current nimo nga muagi sa transformer sa actual. So, kasagaran ang transformer ang gamiton gyud is 3-phase. Ang 3-phase kay full voltage man good ang 3-phase. So, maka-carry siya dako nga kuryente. Likewise sa single phase. Pero ang single phase kasagaran makita ra ni sa balay. So equipment is designed to operate from delta connected power such as kanang air conditioners or motors. Can also operate from Y connected power because ang phase-to-phase voltages are available in both systems. So however, equipment that requires nga Y connected power cannot operate from a delta connected source because the phase to neutral voltages are not available. A special isolation transformer designed to convert delta to Y is needed in this case. So, kailangan ang delta to Y ani. So, sa overcurrent protection device is rated na siya 150 to 200% of the rated primary current of the transformer nga mag-protect the primary circuit on a transformer, so which ensures nga indicate short circuit protection for primary conductors and the transformer, but less opportunity for nuisance tripping. The secondary overcurrent device is set at 125% of full load. So sa next slide. So sa primary and secondary conductors, ang size is to carry 100% of the ampere rating of the overcurrent protection. So the equipment grounding conductor size nimo is based on the ampacity of the base conductors. Ang system grounding of a transformer is required to remove static electricity and if the short circuit develops, such as if the transformer windings come in contact with the enclosure. So based on the ampacity of the base conductors on the secondary side of the transformer. So sa transformer located within kanang building ni siya generally must be located sa transformer closets or rooms or kanang vaults that have adequate fire rating. So they must be readily accessible to qualified personnel for inspection and maintenance. So ang small dry type is mga transformers can be located na siya sa open on walls, columns, or structures or above sa suspended ceiling or in hollow spaces of buildings if they are readily accessible. Generally, ang transformer ma-rated siya 1,121 over 2 kVA or less must have separation from combustible materials of at least 12 inches and those rated above sa kanang 1,121 over 2 kVA malocate ni siya sa an approved transformer room. So, transformer, next slide please. Transformer vaults and rooms must be constructed of walls and ceilings that are structurally adequate and that have at least 3-hour fire rating. So example is kanang 6 in thick and reinforced concrete nimo. So unless nga the vault or room has an automatic fire protection like kanang sprinklers, in which case the rating must be 1 hour. So the vault door must be tight-fitting with a minimum fire-resistant rating of 3 hours, so 450.43 amps. So, ang vault doors must swing out. So, among vault door must swing out be equipped with the panic bars or pressure plates so the door can open from inside under simple pressure and be provided with locks that are accessible only to qualified persons. So ang aim sa transformer bolt is keeping the transformer cool and away from the building occupants. Nothing unrelated to the transformer can go in a vault, that is, it cannot be used as a telecommunication closet or house a water heater. So all transformer installation must provide enough ventilation so the transformer does not overheat. That's all, and that's all to my report, and thank you for listening.
That's all, guys. Thank you for the listening.
Good evening, everyone. We are the Group 1 presenter and we will be discussing these following topics. Chapter 19.11 Occupant Protection Requirements involves here the tamper-resistant receptacle requirements, ground fault circuit protection requirements, and arc fault circuit protection requirements. Chapter 19.12 Electrical System Design involves here the preliminary design guidelines, basic design consideration, design guidelines for common spaces. And lastly, Chapter 19.13 Design Example involves here the circuit design and load computations. I am Kiro Clemens Pedera together with my group mates Christian Clint Acer Malagamba, Don Iconar, Jesrel Vincent Pirian, Monique Aberin, and Christine Asibar. So we begin with occupant protection requirements. First is tamper-resistant receptacle requirements. First thing first, what is tamper-resistant receptacle? Tamper-resistant receptacles are the result of a safety measure set in place by National Electric Code or NEC to help prevent electric shock. Tamper-resistant receptacles prevent electrical contact with foreign objects, thus preventing electric shock and even death. The NEC or National Electric Code has required tamper-resistant receptacles be installed in all 125 volts, 15 to 20 amps electric receptacles in hospital pediatric areas. Recently, the NEC introduced requirements for all 125 volts, 15 to 20 amps electrical receptacles in new residential construction to be tamper-resistant receptacles. Protect the small children from electric burns when they accidentally insert items into the conventional outlets. So kibali, products such as plastic plug-ins insert and wall plates with contact shutters are available for tamper resistance, but do not meet these requirements. There are many other settings where children may be at risk, including daycare centers, children's play areas, elementaries, and nursery schools, and retail establishments for featuring children's attire or toys. Tamper-resistant receptacles should be considered in these areas. Ug please take note nga all tamper-resistant receptacles must have 5 mm height on the device as a clear indication that this is a tamper-resistant receptacle. So, mao ni ang tamper-resistant receptacle. Di-design siya to prevent kids from hurting themselves with fidgeting with an outlet. Na siya two spring-loaded shutters that close the slots when you remove a plug. So, this time, nakipakita na video para mailan ninyo si tamper-resistant receptacle.
Inside there's these little flaps. Basically how a tamper resistant receptacle works is on the inside there's a loaded spring and there's these two little flapped doors on the inside, and the only way to get these flaps to open up to be able to plug something inside is by equal pressure to both of them. So on the hot and the neutral side, when you have a plug like a 15 amp or 20 amp receptacle or a plug and you stick it into the receptacle, both prongs of that plug are applying equal pressure. Now this always doesn't work. Some of them are just pieces of crap, so you have to kind of wiggle them a little bit to get them to work. But either way, it's more work for an adult to try to get something in at the cost of safening your house so that a child can't stick something in. If you try to stick something in just one side, those little springs won't release and both of the doors won't flap open. One of them won't even flap open. So you have to apply equal pressure with both prongs to be able to plug something in. So that's really the best thing for children to not get electrocuted.
So next is the National Electric Code. National Electric Code number 406.12, tamper-resistant receptacles. So it says na all 15 to 20 ampere, 125 to 250 volt na locking type receptacle in the area specified in 406.12. And dwelling units including attached and detached garages and accessories building units, common areas of multifamily dwellings. Mao ni ang common areas, wall space, small appliance circuit, countertop space, bathroom area, outdoors, laundry area, garage and outbuildings, and lastly hallways. Next is the ground fault circuit protection requirements or GFCI. This is a protection is required for 125 volt to 250 volt receptacles supplied by single phase branch circuits rated 150 volts or less to the ground. GFCIs are generally installed where electrical circuits may accidentally come into contact with water. They are most often found in kitchens, bath and laundry rooms, or even outdoors or in garage where electric power tools might be used. Ang National Electric Code nag-introduce of requirements for use of GFCI in residence in 1973 when it required GFCI protection of outdoor convenience receptacle within 2 meter of grade level. In residential installation, GFCI protection is required at all 125 volts, single phase, 15 amps and 20 amps. Muna siya ang ground fault circuit interrupter or GFCI kanina sa figure. So please take a look to the next video about ground fault circuit interruption so you will know how it really works.
Ground fault circuit interrupters, or GFCIs, have saved thousands of lives over the last 3 decades. found mostly in areas where electrical products might come in contact with water, such as bathrooms, kitchens, and outdoors. A GFCI is a special type of outlet designed to cut off power before a deadly electrical shock can occur. For example, when you plug in an appliance like a hairdryer, energy flows from the outlet to the device. A GFCI monitors that amount of electricity. If there's any leakage or interruption of that current, such as when the hairdryer comes in contact with water, the GFCI cuts power to the device in as quickly as 1/30th of a second. Here are a few simple steps to follow. Push the reset button on the GFCI to prepare for testing. Plug a nightlight or similar electrical device into the receptacle. The light should turn on. Push the test button. The nightlight should go off. Complete the test by pushing the reset button again. The nightlight should turn on. If the nightlight does not turn off when the test button is pushed, then the GFCI may be improperly installed or damaged and does not offer shock protection. Contact a licensed electrician to check the GFCI and correct the problem.
Kanina requirements do not apply to equipment rated at 240 volts, example, baseboard heater, room air conditioner, welding receptacles, or other outlets that are not rated at 125 volts. The NEC introduced these requirements beginning in the years listed in parentheses. Outdoor convenience outlets within 2 meters of grade level in 1973 edition and revised to include all exterior convenience outlets in 1993 edition. Next is bathroom convenience outlets in 1975 edition. Readily accessible convenience outlets in garages 1978 editions, except where not readily accessible, such as outlet dedicated to an overhead door opener or freezer. Convenience outlets within 6 feet or 1.8 meter of kitchen sink 1987 edition and revised to include all kitchen convenience outlets that serve countertops including islands. 1996 edition, but not those serving fixed kitchen appliances, example range and oven, and the refrigerator or freezer. Convenience outlets in unfinished basements and crawl spaces, except laundry 1990 edition. Convenience outlets within 6 feet or 1.8 meter of laundry, utility room, or wet bar sink 1993 edition. Other locations required GFCI protection on 120 volt single phase 15 ohms and 20 ohms outlets include commercial kitchens, restrooms in commercial, industrial, and in any other non-dwelling type buildings, receptacles with grade level access and rooftop locations, commercial garages, elevator pits, or agricultural buildings, aircraft hangars with location in healthcare facilities.
So, good evening everyone. I'm Christian Clint Malagamba and I will be the second reporter for Group 1. So, tonight I'll be discussing the arc fault circuit, the electrical system design, the stages of electrical design, and the basic design considerations. So, here are the subtopics. So, the subtopics for each topics. So, in arc fault circuit, let's talk about what is an arc fault. the AFCI or the arc fault circuit interrupter, and the connection between AFCI and GFCI. Next is the stages of electrical design. So let's talk about the four stages in electrical design: the conceptual design stage, preliminary design stage, developed design stage, and the detailed design stage. Next is the electrical system design. So what is electrical design and electrical system design and electrical standards? So lastly, the basic design considerations. These are the typical issues to be considered in every design stage. So first, let's talk about the arc fault circuit. So when we say arc fault circuit, it is when a loose or corroded wiring connections create an intermittent contact that causes electrical current to spark or arc between metal contact points, which may create heat and the potential for electrical fires. So arc fault circuit may be a precursor to a short circuit or ground fault, but ang kalahian sa arc fault kay is either dili mag-shutdown ang GFCI or ang circuit breaker. So arc faults in a home are one of the leading causes for household fires. So in order to avoid this kind of situation, so we have the arc fault circuit interrupter. So ano siya? So an arc fault circuit interrupter is a circuit breaker designed to prevent fires by detecting a non-working or non-intended or non-useful electrical arc and disconnect power before the arc starts a fire. So an arc fault circuit interrupter is really important to avoid this kind of situation. So in 1999, the code began requiring AFCI protection in all circuits feeding bedroom outlets, and beginning 2014, nearly all circuits supplying general outlets in living spaces are required to have AFCI protection in new construction or in remodeling projects. So as of the 2017 edition of the NEC or the National Electrical Code, the wording of section 210.12 states all 220 volt single phase 15 and 20 ampere branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, etc., or similar rooms or areas shall be protected by FCIs. So, sa Pilipinas, sa PEC or the Philippine Electrical Code, all single-phase 15 and 20 ampere branch circuits supplying outlets installed in dwelling unit bedrooms shall be protected by listed AFCI. So the combination type installed to provide protection of the branch circuit. So important note that it is important to understand that AFCI does not take the place of GFCI protection. It is because ang ground fault circuit protects against the shock only. Dili pareha sa AFCI nga makaprotect siya sa against sa kalayo. So pero kadaghanan sa mga locations kay ga-require jud og GFCI o AFCI protection at the same time. For example, installan og AFCI circuit breakers, then parisan po dayon og GFCI nga receptacles sa specific nga location, or napod combination sa sa AFCI o GFCI nga circuit breakers that can offer both types of protection sa entire nga circuit. So next is the electrical system design. So what is an electrical system design? Electrical system design solves challenges which are related to design and development to ensure that are economical, safe, and reliable. These are groups of electrical components that are connected to carry out some operation. This includes electrical layouts, lighting, earthing, and voltage drop. So here an example of electrical design of the on-site generation system. So one key element for understanding and communication of the electrical system design is a one-line diagram such as the one depicted in the figure. So the electrical installation of the generator set and its accessories must follow the electrical code in use by local inspection authorities. Electrical installation should be done by skilled, qualified, and experienced electricians and contractors. So electrical standards need to be followed in workplace to protect the integrity of the building as well as make sure that the employees stay safe while on the job. That includes preventing electrical shocks, electrical fires, and other electrical hazard related issues. In any system design, local codes and standards will have a significant impact on the overall system design, hardware, and other application details. So it is really important to know the and apply the standards because it will be like a domino effect, bitaw. So if the intended design or modification work ay wala na ayon sa local codes and standards. So before actually beginning the design layout of the project, the designer will need to accumulate certain information. So first is that to determine whether electrical service is available at the site. So, and what type of the system voltage is available. Like for example, 120 over 240 volts AC. No? So service is not available. Arrangements must be, if service is not available rather, arrangements must be made with the power company to extend service to the building site. The second, obtain a list from the owner of all the types and locations of equipment and appliances to be used in a building that will require electricity. Although the electrical design may be aware of the electrical requirements for such of the equipment, it may be necessary to find the manufacturer's specification for certain equipment, like for example the motor sizes, the power and system voltage required. Third is to work with the architectural designer to best locate of all of the electrical equipment and appliances on the floor plan. So in commercial projects, they sometimes take several meetings with the architects, engineers, consultants, owners representatives, and manufacturers representatives. So there are times when the type of equipment used and its location must be approved by government agencies. So fourth, we need to review with the architect where the basic mechanical equipment, like for example HVAC and plumbing, the service entrance equipment, the power and lighting panels, and the conduit or a cable will be located. And lastly, discuss with the owners and future plans for changing or expanding the facilities. For example, remodel mo or constructing additional or other buildings or future equipment requirements. So, and anything else that could potentially affect the size and location of the electrical service. the service entrance must be sized to anticipate future expansion as well as building plans. Once the basic information has been gathered, the designer can begin to design the system itself. Has been gathered, the designer can begin to design the system itself. So next, let's talk about the stages of electrical design. The electrical design includes 4 stages as follows. First is the conceptual design stage. The second, preliminary design stage. Third, develop design stage. And lastly, the detailed design stage. So first, what is conceptual design, the first stage? So this phase places the greatest demand on the designer in terms of creative thinking. When the designers choose a solution, they must also think about, is there a way to achieve the same purpose with a different, easier solutions? So these are outline solution for a required design. So many examples sa conceptual design stage. So there is a conceptual design stage is kanang framework lang siya, and syempre dapat ang design is feasible as well as iyang functionality is simple. So the typical activities during the conceptual design. So here are some of the activities na na dapat mahuman sa usa ka electrical design team during the conceptual design. First is review of client requirements, including reliability, redundancy, and efficiency. Second, establish design criteria and develop functional services brief. Third, investigate interface requirements with existing buildings and equipment. Fourth, establish hazardous area classification if applicable. Fifth, review preliminary fire safety report. Sixth, review applicable authority codes and standards katong PEC or NEC ba? Itong National Electrical Code or Philippine Electrical Code. 7. Establish contacts with utility companies. 8. Calculate total loads estimates. 9. Assign main supply methodology. 10. Assign standby power requirements. 11. Assign main plant space requirements. Next is to assign emergency lighting concept. The 13th, assign earthing methodology. And lastly, to review concepts for significant and unusual health and safety risks relevant to design. So here are the outputs in conceptual design stage. So in drawings, natay sketch drawings that may compromise or mark up architectural drawings, including preliminary plant room requirements and service routes. So for the specification, there are no specification can be produced at this stage. And for the reports, the first is the concept services brief. So to establish available system concepts and a broad report investigating available options and recommendations and definition of system requirements and key assumptions. Second, design standards to be used. And for the important note for conceptual design, first is concept and preliminary design phases are often combined on smaller projects. The second is tendering at this stage unlikely to result in like-for-like bids. And lastly, no coordination completed at this stage. Next, the preliminary design stage. At this stage, preliminary design stage bridges the gap between the conceptual design and the developed design phase. In this task, the overall system configuration is defined and layouts of the project will provide early project configuration. Here are the typical activities during the preliminary design. First is to assess the supply utility requirements and local authorities. Second, initial sizing of major plant. For example, the transformers, generators, and main switchboards. Third, load estimates based on major plants plus what's over the area for general areas. Fourth, identification of major service routes. Fifth, location and capacity of main load centers. So next is to general area lighting layouts. Next, general area power distribution methodology, using of perimeter trunking, etc. 8. Develop services route requirements, both horizontal and vertical, and space coordination with other trades. 9. Define interfere requirements with other services. And 10th, lastly, and surge protection requirements. Ay, po the 11. 11th, identify any special health and safety risks that may present in construction or design and consider alternative lower risk options. And pinaka-last, final na jud, review preliminary design for significant and unusual health and safety risks that the design may present during construction and maintenance. So for the outputs in preliminary design stage, we have in the drawings, we have 3, the single line diagram showing major plant and major distributions, like the breakers and cables and size. Second is to the layout drawings indicating plant room locations, risers, and primary service routes. Third, typical area lighting, like the reflected ceiling plan and power layouts or schedules. So for the specifications, we have the outline specifications, preliminary equipment schedules for major plant, and generic lighting appliance types. For the reports, design features report with agreed option to take to develop design stage. Second, preliminary electrical equipment heat loads. Third, energy efficiency analysis. So, and we have lighting protecting assessment. For fifth, preliminary building services interface metrics. And lastly, we have highlight or significant and unusual buildability and health and safety issues. So important note for preliminary design stage is cost estimates at this stage generally cannot be on a full elemental basis as final distribution is not well defined. Second, systems could be priced by vendors at this stage, but unlikely to get like-for-like comparison. Next is the develop design stage. The develop design stage focuses more on the technical aspects of materials and building systems. So diri kay makita na nato ang mga complicated na drawings like kanang daghan na siya details and all. Pero sa next stage, makay mas daghan pag yun na siya details o mas refined compared diri. So in developed design stage is the period when all the issues left unresolved at the end of the preliminary design can be worked out and at a scale that minimizes the possibility of major modifications during the developed design stage. It is also the period in which the design itself achieves the refinement and coordination necessary for a really electrical design. So muna example sa developed design stage. So here are the typical activities during the developed design stage. First, elemental load assessments, including the documentation of constraints. And we have fault level calculations. And third, lighting calculations and layouts. Determine number of power outlets on area by area basis. Fifth, control methodologies. 6, finalize earthing requirements. 7, major plant and services routes, including access for installation and maintenance, coordinated with architecture, structure, and other trades. 8, develop and expand the services concepts, selection of typical plant, review of plant room sizes, and service space requirements, including the sizing of mains, sub-mains, and protection. 9, assessment of specific treatment harmonics, both the internally and externally generated. 10, identify utility connections. And last, we have the very significant and unusual health and safety issues have been addressed in the design. Next is the outputs in developed design stage. So in drawings, we have single line diagram showing connections to all equipment and boards. For example, the breakers and the cables are sized. Second, layout drawings indicating plant room locations, risers and service routes, and main cable trays. And we have lighting and power layouts. And lastly, we have reflected ceiling plants with preliminary coordination. So for specifications, we have the preliminary technical specifications and the equipment schedules. For the reports, updated design features or options report, including options selected. Supply authority approval submissions, updated energy efficiency review, building services interface metrics, and lastly, we have highlight significant and unusual buildability and healthy and safety issues. So the important note for developed design stage, the cost estimates at this stage can be produced by quantity surveyor on elemental basis with the secondary elements estimated on typical details. So developed design generally provides the minimum level of documentation to clearly define the scope of all electrical elements. So the last stage, the detailed design stage, or the fourth stage, electrical designing. So during this stage, the electrical design team uses both the requirements specification and the preliminary technical specification provided by the previous stages to develop a detailed design of the system. So this system will provide a detailed specification for each component, thoroughly describing interfaces and functions provided by each component. So this detailed design will serve as the basis for the construction stage. So at this stage is where the details are more refined kay included na ang ang specs sa each nga component. Labi na tong mga mga critical areas as well as the schedule. So as you can see kaning nanay tables para sa schedule sa mga load for each electrical component og napo din na tanan ang mga calculations. In detailed design stage, we have a typical activities such as the detailed load assessment, equipment sizing and generic selection, supplies to ancillary systems like the public phones, fire alarms, fire alarm panels, etc. The sub-circuit cable sizing and breaker selection discrimination checks, coordination in principle with structure, architecture, and other building services, design of harmonic treatment, finalize utility supplies, and lastly, we have highlight significant and unusual health and safety risks that were identified through the design process. So for the outputs in detailed design stage, for the drawings, we have the single line diagram showing connection to all equipments and boards, breakers and cable size. We have also the layout drawings indicating plant room locations, risers and service routes, and main cable tray routes. Third, the plant room and riser outline layouts. Fourth, lighting and power layouts including switching and circuiting, lighting control zoning and specification. And lastly, we have distribution schedules with final circuit, breakers, and cables size. So for the specification, we have the detailed technical specifications, detailed equipment schedules, and lastly, the luminaire and fitting schedules. For the reports, we have no reports will be issued during at this stage. Important note for detailed design stage. Detailed design stage generally provides a level of documentation to clearly define the design of all electrical elements. Design details should be coordinated with other disciplines. However, the documents produced in this phase may not directly be able to be built from. So second, coordination in ceiling zones identified with the appropriate clearance from structure and other services, major penetration identified, detailed coordination of critical areas. Next, define in the specification the significant and unusual health and safety risks that were identified in the design. And lastly, take note, after finishing the detailed design stage, a new stage will start called construction design stage that usually prepared by services subcontractor to enable fabrication of the services design. But it is not under the direct scope of the electrical design team, so but it must be monitored by them based on their contract, base pod sa ilang contract sa ilang client. So next is the basic design considerations. So we have typical issues to be considered in basic design. So in each stage, there are issues put. So first is the conceptual design stage. First, feasibility of alternative sites. Regulatory restrictions such as the parking, zoning, building codes, or disabled access. Natural conditions like the topography, climate, considerations, and orientations. Fourth, input from consultants, for example, the landscape architect, geotechnical engineer, civil engineer, etc. Fifth, input from groups with jurisdictional interest, for example, the environmental impact statements. Six, input from public agencies such as zoning, planning, building department, and fire department. 7. Environmental hazards. Next, input from groups with community interest. For example, community organizations and historic preservation organizations. And lastly, access to the utilities. So, syempre, we need to consider po na if naa tayo access sa utilities before proceeding the design. Kay lisod po kung mag-install tag electrical design sa usa ka building pero wala kuryente didto. Next is the preliminary design stage. So there are also issues po na that are needed to be considered. First is the client approval of concept services, design, and budgetary implications. Next, updated fire engineering report. Third, power authority requirements or constraints. Fourth, client approved architectural, structural, and other services concept designs. Fifth, design time schedule. Sixth, preliminary service loadings. Seventh, long-term flexibility plan for growth and adaptive reuse. Eighth, cost and schedule implications of design choices. And lastly, we have refinement of design ideas. So it is based on natural conditions in order to optimize building performance. In develop design stage, client approval of preliminary design and budgetary implications. Second, client approved architectural, structural, and services preliminary designs. Third, service loads. Fourth, define escape routes with locations for emergency signage. Fifth, furniture layout and interior design. And lastly, landscape layout and connection to building. Next is the typical issues to be considered in the detailed design stage. So first, we really need to consider the client approval of developed design and budgetary implications. Second, client approved architectural, structural, and other services developed designs. So, any question? So that's all for my report. I hope you guys learned so much, and if you have any questions or clarifications, you may send it to the chat box sa Meet na to karon. So,
Good evening, guys. My topic for this night is about design guidelines for common spaces. So let me start first on convenience outlets and switches. In this area, you need to remember the following. The number and the type of lighting outlet should be fitted to the varying task. Lighting outlets should be located to meet the desired lighting effects and fixtures to be used. All convenience receptacles on 15 amperes and 20 ampere general purpose circuits should be of the grounding type, minimizing the hazard shock from short circuits. A protection or ground fault circuit interrupter can help prevent electrocution, thus it should be provided on convenience receptacles. AFCI protection or arc fault circuit interrupter is a device intended to protect against the effects of arc faults by recognizing characteristics unique to arcing and then de-energizing the circuit when it detects an arc fault. Thus, it should be used on convenience receptacles. All rooms that have more than one entrance should be equipped with multiple switch controls. Wall switches should be located at the lock set or latch side of doors. Convenience receptacles in living rooms, bedrooms, dining areas, and other habitable spaces should be placed so that no point along the floor line in any usable wall space is more than 6 feet or 1.8 meter from an outlet in that space. Next area is on building exteriors. So on building exteriors, one should be located at or near all exterior entrances. For each single-family dwelling, at least one duplex receptacle should be installed outdoors to be readily available from ground level. One or more outlets may be required for exterior equipment. Outlets for ambient and task lighting should be provided. Convenience receptacles in living areas should be placed. One or more receptacles or entertainment equipment should be provided at bookcases, shelves, or other suitable location. When general illumination is to be provided from portable lamps, then at least two separate wall switch plug-in positions should be provided. An outlet for a fireplace may be required. A smoke detector or alarm on a 120-volt circuit should be considered. Next area is on food preparation or kitchen or cooking areas. First, lighting for ambient and local or task illumination of the work areas, sink range, counters, and tables. Lighting outlets should be switch controlled. Special purpose and receptacles should be provided for all fixed appliances. At least 20 small appliances circuits for kitchen countertops should be provided. One receptacle for each 2 linear feet or 0.6 meter of work surface face. At least one receptacle to serve each separate work surface. Convenience receptacles serving countertop areas. A small or detector alarm 120-volt circuit should be considered. Next part is sleeping areas and bedrooms. General illuminations should be provided from either ceiling or wall outlets, controlled by one or more wall switches. The convenience receptacles should be placed on each side and within 6 feet or 1.8 meter of the center line of each probable individual bed location. All 120-volt branch circuits that supply outlets in dwelling unit bedrooms must be protected by an AFCI device. A smoke detector or alarm must be provided on a 120-volt circuit and should be AFCI protected. In master's bedrooms, outlets should be considered for a television and entertainment equipment such as DVD or VCR player. And also, an outlet for a fireplace in this area may be required. Next area is on the bathrooms or restrooms. Lighting sources at the mirror should be capable of illuminating both sides of the face. At least one GFCI protected receptacle within 3 feet of the outside edge of each lavatory basin should be provided. A wall switch or timer operated built-in ventilating fan capable of providing a minimum of 8 to 10 air changes per hour per water closet or 50 CFM per water closet should be provided. Wall switches should be located so as not to be readily accessible when standing in the tub or shower stall. Next area is on the laundry areas. Outlets for fixed lights should be installed to provide illumination of work. In the laundry area, 120 ampere receptacle for the clothes washer and a special receptacle for the clothes dryer are required. One outlet and one switch for a ventilation fan should be provided. A smoke or detector alarm on a 120-volt circuit should also be considered. Next part is on the halls and corridors. Ceiling fixtures should be installed for proper illuminations of the entire area with a particular attention paid to irregularly shaped spaces. Convenience receptacles in hallways within a dwelling unit should be placed so that no point in the hallway shall be more than 10 feet or 1 meter from a duplex receptacles, as measured by the shortest path that the supply cord of an appliance connected to the receptacle would follow without passing through an opening fitted with a door, or the vacuum cleaner rule. In the entrance foyers, convenience receptacles should be placed so that no point along the floor line in any usable wall space is more than 10 feet or 3.1 meter from a receptacle in that space. Next part is on the stairways. A fixed wall or ceiling lighting outlet should be installed to provide adequate illumination of each stair flight. Outlets should be arranged that the stair system can be fully illuminated from either floor. A smoke or detector alarm on a 120-volt circuit should be considered at the top of the stairs. Next area is on the utility rooms. Outlets should be placed to illuminate the furnace or boiler area and work area. Convenience receptacles should be provided. Outlets should be provided for each piece of mechanical equipment requiring electrical connections. A special purpose outlet may be required for electric resistance, water heat, and or an electric resistant furnace. Next part is on the shops and garages areas. Lighting outlets should be placed to illuminate the work areas. At least one duplex receptacles should be provided for each space in a garage or carport. Convenience outlets should be provided at workbenches. Outlets should be provided for automatic overhear or garage door operators in the ceiling above each bay. Special purpose outlets should be provided for special equipment. A smoke detector alarm on a 120-volt circuit should be also considered. Next area is on the short storage rooms and closets. Generally, one lighting outlets for each large closet or storage room should be provided. Where shelving or other condition makes the installation of lights within a closet ineffective or unsafe, receptacles in the adjoining space should be so located as to provide light in the closet. Wall switches or automatic door switches are preferred, but post switches are acceptable. Last but not least, on the electrical telecommunications closets areas. Lighting outlets should be placed to illuminate the area. A minimum of 2 dedicated convenience receptacles on separate circuits is required. Additional duplicate convenience receptacles should be placed at 6 feet or 1.8 meter intervals around the perimeter. Rooms should be located away from sources of electromagnetic. Emergency power should be considered and supplied. And lastly, a smoke or detector alarm on a 120-volt circuit should be considered. So that's all about my report.
So that's all for our last reporter. The following reporters will be reporting next week. Thank you.
Okay, so thank you sa mga reporters karong gabi. Maduog ko ninyo.
Yes, sir.
Yes, sir.
Nako ihatag sa inyo nga project nga deadline is April 9 at 11:59 PM. Ako lang i-send later sa GC. Tapos by next week after sa report, prepare for a quiz and maghatag sad kog prelim sa inyo ha. So dili lang nako ipa-submit diretso tagalang tamo og mga pila ka days para submission sa duha. Tapos ang atong schedule for the exam is on April 8 at 1:30 PM to 4:30. So 3 hours ni siya. So ang coverage by the way sa atong prelim and midterm is the topic from the start. So chapter 17 to chapter 19 ang coverage na to. Sa pababe?
Sir, ang PIT, sir, kay by group?
Individual. Individual ang pit ninyo. Kuan ra siya, ingani ang basic basic idea sa akong pabuhat. Gusto lang ko magpabuhat og ganang gamay nga floor plan like single story lang tapos tagayin ako kanang kanang mga lighting and outlet na mga wiring and schedule of loads kana lang. Basta i-send lang ako ang details later sa katong.
Okay, sir. Thank you.
Naka-example, sir?
Ah?
Example, sir ba?
Sige, mag-send ko within the week ng example sa inyo.
Okay, sir. Thank you.
Unsa pa may mga questions na to so far? So, kung wala na may questions, no, pwede na tayo mag-class dismiss. So, thank you sa pag-report ninyo, guys, despite nga absent ko. So, prepare sa inyong midterm and quiz para next week. So, wala to. Good night and thank you sa inyong tanan.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.